In this video, we are going to be learning about the properties and changes of matter, including physical properties, physical changes, and chemical changes. When we are in the lab, we make observations and collect data. The observations and data we collect can be either qualitative or quantitative. The word qualitative sounds like the word quality, while the word quantitative sounds like the word quantity. This can help us remember the difference. Qualitative data consists of descriptions that do not have numerical values. These are often observations made using our senses, such as what we see, hear, smell, taste, or touch. However, in the laboratory, we should not taste or smell substances for safety reasons. Quantitative data involves measurements with numerical values, such as counts, dimensions, temperatures, volumes, distances, and masses. These measurements typically include both a number and a unit. When we make observations or collect data, we may be observing physical properties or chemical properties. Physical properties are properties that can be observed without changing the composition of matter. Examples include color, state of matter, boiling point, and freezing point. For example, I could describe this ice. I would say that it is a transparent, colorless solid. If I look at this mixture of baking soda and vinegar, I could describe the baking soda as a white powdery solid, or the vinegar as an amber-colored transparent solution because this is apple cider vinegar. Substances can exist as solids, liquids, or gases. These are known as the states of matter. The same substance can exist in different states depending on the temperature and pressure. You are probably most familiar with water existing in all three states: ice, liquid water, and water vapor. If you encounter a liquid at room temperature, it means that room temperature is warm enough that that substance has already melted. If you encounter a gas at room temperature, it means that room temperature is above the boiling point for that substance. Many colorful periodic tables use the color of the element's symbol to indicate the state of matter at room temperature. The color code used by many periodic tables is as follows with this terrible poem. Gases are red, liquids are blue, the rest are solids. That's all you need to know. I recognize that that poem is grammatically incorrect, but that's just so it rhymes. Data is often collected while matter is undergoing a change. Sometimes those changes are physical changes, and other times they are chemical changes. Physical changes do not change the chemical composition of matter. The chemical bonds are not broken. Instead, particles are simply rearranged or separated. For example, if I boil water, it changes from liquid water to water vapor, but it is still water. If I cut a piece of paper, I have smaller pieces of paper, but I still have paper. If I filter coffee, I can separate the coffee grounds from the brewed coffee, but I still have coffee grounds and I still have coffee. Before we describe physical and chemical changes using chemical symbols, we need to cover some basic chemical symbolism. On this slide, I have 4 images involving hydrogen atoms to show you how numbers are used in chemical notations. The first image shows one hydrogen atom, which is represented simply by H. The second image shows 2 separate hydrogen atoms that are not connected. Since they are not connected, we write a 2 in front of the H, 2H. This indicates that we have 2 identical hydrogen atoms. The third image shows one molecule made out of 2 hydrogen atoms bonded together. Because the atoms are connected, we write an H with a subscript 2. The last image shows 2 H2 molecules. The 2 in front indicates that there are 2 molecules, while the subscript 2 indicates that each molecule contains 2 hydrogen atoms. The placement of the number determines its meaning. Now we are going to look at a physical change at the molecular level. Before the change occurs, there is a mixture of N2 and H2 molecules. After the physical change occurs, there is still a mixture of N2 and H2 molecules, but the arrangement of the molecules has changed. Before the change, the molecules are spread out throughout the container, indicating a gas. After the change, they have formed an ordered solid. A change in state of matter is a physical change. Chemical properties can only be observed when matter changes composition. Examples of chemical properties include flammability, acidity, and toxicity. When a substance burns, it changes composition. If a person ingests a toxic substance, chemical reactions occur within the body, which is why toxicity is considered a chemical property. Earlier, I showed a picture of baking soda and vinegar and described their physical properties. If I mix baking soda and vinegar together, I can observe a chemical change as carbon dioxide gas is produced during the reaction. Chemical changes involve changing the composition of matter into something new. Examples of chemical changes include burning, rusting, and aerobic respiration, which is the chemical reaction occurring in your body every time you breathe. Other examples include dyeing hair and baking. During a chemical change, chemical bonds between atoms are broken and new bonds are formed. The atoms themselves do not disappear, instead, they become connected in new ways. Here we see a chemical change at the molecular level. Before the change occurs, we have a mixture of N2 molecules and H2 molecules. After the chemical change occurs, the molecules are now NH3 molecules, which contain 1 nitrogen atom bonded to 3 hydrogen atoms. Before the reaction, nitrogen and hydrogen atoms are not connected. After the reaction, new bonds have formed between nitrogen and hydrogen atoms. Now it is your turn to practice drawing a physical change and a chemical change. This box contains 3 molecules, each made of 1 circle and 2 triangles. For the physical change, remember that no bonds are broken. We still need to have 3 molecules containing 1 circle and 2 triangles. We can separate the molecules or rearrange them, but we cannot break the atoms apart. For the chemical change, we need to change how the atoms are bonded together. There are multiple correct answers. You could connect all 3 molecules together to form 1 larger molecule, or separate the atoms so that no triangles are bonded to circles, or recombine the atoms in a different arrangement. The key is the connections between the atoms must change. Elements on the periodic table are arranged in columns called groups. Elements within the same group have similar chemical properties because they have similar electron configurations. For example, elements in group 1, the alkali metals, all have 1 valence electron in the s subshell. Elements in group 17, the halogens, all have 7 valence electrons, 2 in the s subshell and 5 in the p subshell. Here's another practice problem. Read the following observations and data collected in the laboratory and identify whether each describes a chemical property or a physical property. The first statement says the substance is a silvery white, lustrous metal. This describes a physical property because we can observe the color and shininess without changing the composition of the metal. The second statement says it melts at 649 degrees Celsius and boils at 1105 degrees Celsius. This is also a physical property because states of matter and the temperatures in which phase changes occur are physical properties. The third statement says the density at 20 degrees Celsius is 1.738 grams per centimeter cubed. Density is also a physical property. The final statement says that the substance burns in air and produces an intense white light. This describes a chemical property because burning is a chemical reaction. The reactivity of a substance is a chemical property.